hello and stuff. This could just end up being a massive bunch of awkward, so I'm just gonna do it. Ionisation energies and orbitals. Woo! What is it? Now you're probably thinking, yeah, what is it? Because we can't do chemistry. So I'm going to explain. Yay! Okay, with aid of post-its. This could go wrong. Ionisation energy is the energy needed to remove 1 mole of electrons from each atom in 1 mole of gaseous atoms to form 1 mole of gaseous ions. Now if you don't remember that in the exam, going with post-it notes all over a face, you've got something wrong with you. 1, 2, 3. Okay? Cool. Sometimes they ask you for equations. An example would be magnesium, gas. You need to remember the gassy bit because otherwise you don't get the mark. Cool? Okay, magnesium gas goes to magnesium gas, but it's a plus. Why is it a plus? Well, because you're removing an electron, so it becomes positively charged. Ion, boom, ding, cool. You might have seen some scary graph that looks like this. Don't take this into account, it's probably quite wrong, but it looks a bit like this. And what it means is the first electron is really easy to remove from the atom. Why? I'll tell you why. It's easiest to remove because it's the outermost electron is furthest away from the nucleus, so it's less shielded, more shielded from the nuclear charge, which means that less energy is needed to remove it because it's not being pulled in as much as these are. Also, this is sodium, which is a nice example because it's only got 1 on the outer shell. They might also ask you why the second ionisation energy, I can't say this word, ionisation energy is bigger than the first. Well, I'll bring out sodium again, because if you take this one away, the rest of the electrons are in a different shell, closer to the nucleus, which means they're less shielded than this one was, which means more energy needs to come to steal them, like sweeties, because they're fat. Also, a nice phrase to use is that the ionisation energy increases with electrons, subsequent electrons, because you're taking an electron away from an increasingly positively charged species. I don't know what that means, just use it, okay? Just embed it in your brain and just use it. You might have seen something scary like this. Ooh, how did we get there? 1s squared, 2s squared, 2p sixed, 6, 3s squared, 3p6, 4s squared, 3d10. Oh wait, what? It's like 3 and 4? Yeah, because the 4 comes before the 3d, which can hold 10. See, it's like I just went back in time and stuff. I know my editing skills on this are going to be terrible, but the magic of video. But the thing you need to remember is that the 4s comes before the 3d only if there's less than 30 electrons in the thing. If there's more than 30, then the 3d will be filled before the 4s, because it's more stable when you've got that many electrons. Now these little mini letter things are called orbitals, and an orbital is an amount of space where there's a 99% chance of finding an electron. Trends. It's like fashion. What happens when we go down the groups? The size of the atom, or the atomic radius, increases, which means the outermost electron is further from the nuclear charge. And because it's further, it's more shielded. Like sodium, look. Because it's further, it's more shielded. Which therefore means it's easier to remove. Woo! However, don't be all like, oh, I know everything, because you don't. Because across the group it's different. Across the group there are more protons and an increased nuclear charge. Which means the electrons are pulled in further by the nucleus. Which means smaller atomic radius, which means the atom is smaller. Which therefore means, yeah, I did the triangle-y stuff, which therefore means it's harder to remove an electron from the same shell. As you go down the group, the thing gets bigger and it's easier to remove an electron. As you go across the group, the thing gets smaller and it's harder to remove it because it's closer to the nucleus. So, to recap, please don't go forgetting this. Oh, it's fallen off. Please don't go forgetting this. Screenshot this one. And this also happens. Yay!